Okay, now in the last video we did a review of arithmetic sequences, and in this video we'll take a quick look at how to find the sum of an arithmetic series. Now first of all, let's talk about what the difference is between an arithmetic sequence and an arithmetic series, just to remind you. And an example would be this. If you had an arithmetic sequence, it's just the terms. So you would have 3, 7, 11, 15, whatever, and you would have the terms of the sequence. Now, if you take the terms of the sequence and add them together, then you have an arithmetic series. So what we want to do is to find the sum of an arithmetic series. And you might remember this formula from your algebra days. Now, the idea is to find the sum of the first n terms of an arithmetic series. All you need, if you know the first term and you know the nth term, then you can use this formula to find the sum. So you need two things, first term and the nth term. So let's take a look at an example and see how this looks. The first example looks like this. Suppose you wanted to find the first 15 terms of this arithmetic series. Now it goes like this. Now again, one thing I would do is the same suggestion that I gave you last time, is actually draw the thing out and label a few terms. So this is going to be a sub 1, this would be a sub 2, and somewhere way out here is a sub 15. And that's what I need to find a sub 15. So I want to have, this is going to be a sub 1, and this will actually be the term that we're looking for. So we'll call this n is equal to 15 in this example. Okay, so to find the sum, let's go back to the formula. You would need this. You need the first term, and you need the nth term, which in this case would be the 15th term. But you've got a problem in that you don't know what the 15th term is. So let's go back to our thing. We need to find the 15th term. So to solve this problem, the first thing you're going to have to do is figure out what a sub 15 is. So we will go back and just remind you of that formula. Now this is from the previous video. If you know the first term and you want to find the nth term, you can use this formula if you know the common difference. So this is the formula that we'll use to get it, but it's going to take a few steps to get there. So let's run through them. Okay, now the first step is going to be, you need to find the common difference, because to use this formula you need the first term and you need the common difference. So the first thing we'll do is find that common difference. So this is going to be step 1. So step 1 is to find the common difference. So to find the common difference, and again, just to remind you from the formulas, common difference is just the second term minus the first term, or the difference in any two consecutive terms. So in this case, I'll just use these right here. I've got a sub 2 minus a sub 1. So in this case, that would be 7 minus 3, which would give me 4, and that's going to be the common difference. So the difference between this term is 4, the difference between this term is 4, and so on. The difference between all the terms is 4. Okay, now that you've got the common difference, let's go back to the formula. Now you want to find the 15th term. So a sub n is equal to a sub 1 plus 1 minus 1, or n minus 1 times d. And let's go ahead and use that. So step 2 will look like this. So step 2, find a sub 15. So you need to know, what is this 15th term? Well, again, we'll start with the formula. A sub n is a sub 1 plus n minus 1 times d. So the things that we know, we're looking for a sub 15. You know the first term's 3. Then n minus 1, in our problem, we're at 15, so we've got 15 minus 1, and from the previous step, we know the common difference is 4. So that's going to give you 3 plus, and 15 minus 1 would be 14 times 4. So a sub 3 would be equal to 3, and 14 times 4 would be 56. And add those together, and you get the 15th term, which is a 59. Now, what I do is come back up and just go ahead and put the 59 in right here. So the first term is 3, and the 15th term is a 59. So now you're ready for the third step. So what step 3 is is just find the sum. So what you want to do is find the sum of the first 15 terms. And to do that, just a reminder of the formula. The formula says that the sum is equal to n times a plus 1 plus a sub n divided by 2. So we use that formula. So s sub n would be equal to n times a sub 1 plus a sub n all divided by 2. We want the sum of the first 15. So n is going to be 15. A sub 1 is a 3. A sub n, in our case a sub 15, is a 59. All divided by 2. So the sum of the first 15 would be 15, and add these two together, and you'll get a 62. So I've got 62 divided by 2. And if you put all this together, you'll come up with 465. So the sum of the first 15 terms, if you added all these things up, they would be equal to 465. But again, just a reminder, to use this formula right here, you need the first term and the nth term, the 15th term. But the trouble is, when you began the problem, you didn't know what the 15th term was. So kind of 3 steps. First step, you have to find the common difference, which is what this is right here. You know the difference between the terms. And the reason you need the common difference is that you have to put it in right here. So once you've got the common difference, then you can use that to find the 15th term. So now you know the nth term. So you need the first term and the nth term, and by following these steps, you've got the first term and the nth term, plug them into the formula, and that's what it looks like. So there's the first example, and let's take a look at a couple more just to make sure. Okay, now in the second example, it wants to know what's the first 12 terms, sum of the first 12 terms of this arithmetic series. And in this example, sometimes you can have a positive difference, sometimes you have a negative difference. In this case, we have a negative difference, but we'll follow the same 3 steps. So again, step 1 is going to be to find, actually I'll label a couple things here. I want to label this as a sub 1. So this would be a sub 1, this will be a sub 2, and somewhere way out here again is a sub 12. So in this problem, n is going to be equal to 12. I want the sum of the first 12 terms. But just like in the previous problem, you don't know what it is. So to start with, same 3 steps. Step 1 is to find the common difference. So step 1, find the difference. So again, the difference is a sub 2 minus a sub 1. So that would be 7 minus 13. Or in this case, the difference would be a negative 6. So the difference could be negative. So that means that this difference is a negative 6. From here to here, it's a negative 6. So between each step, it drops by 6. Okay, now again, to find the sum, let's take a look at our sum formula. You need the first term and the nth term. So again, we're going to have to find the nth term. Now to find the nth term, we'll have to use this formula right here. If you know the first term and the difference, you can find the nth term. So let's go ahead and do that. So this is going to be step 2. So what step 2 is, will be to find, in this case we want the 12th term, we want to find a sub 12. So to find a sub 12, again, we'll just start with the formula. A sub n is a sub 1 plus n minus 1 times d. So in our case, we want the 12th term. The first term would be a sub 1 plus, and we want 12 minus 1 times the common difference. So again, a sub 12 would be equal to the first term is a 13, plus this would be 11, and you know the common difference is a negative 6. So this would give you the 12th term would be equal to 13 minus, and this would be 66. And if you subtracted those two, then you come up with a negative 53. 3. So what this is the 12th term. So I'd come up here and put a negative 53 right here. So they're decreasing all the way. And now finally the last step, so step 3, is to find the sum of the first 12 terms. Now again, the formula is just n times this right here. So you've got the first term and you've got the 12th term. So let's go ahead and plug that in. So S sub n would be equal to n times a1 plus a sub n divided by 2. So the sum of the first 12 terms, n is equal to 12. The first term is a 13. The last term is a negative 53. And it's all divided by 2. So this is going to be sum of the 12. This would be 12. And this will turn into a negative 40 divided by 2. And if you put that on a calculator, you would have a negative 240. So in this case, the sum of the first 12 terms turns into a negative number. So this would be a negative 240 up here. So again, the same 3 steps that you used last time. First of all, find the common difference. Then you need to find the nth term, which in this case is the 12th term. And when you've got the first term and the nth term, you can use this formula to find the sum. And let's take a look at one more example, this time that involves fractions. Again, I want the sum of the first 10 terms of this arithmetic series. So again, I'll do the same thing I've done before. I'll label the first few. So this is going to be a sub 1. So starting right here, I've got a sub 1. This would be a sub 2. And somewhere out here is the 10th term. But again, I don't know what the 10th term is. So I have to follow the same 3 steps that we did last time. So again, step number 1, I need the common difference. So step 1 will be to find d. And d is just equal to the second term minus the first term. So d would be equal to, in this case, a minus 1/2 minus a minus 1. So that'll be a minus 1/2 plus 1. So the common difference is going to be 1/2. So I've got the common difference. Okay, we go to step 2. So step 2, again, to use the formula, I need the 10th term. So I want to find a sub 10. And again, the formula that I'll use is right here. A sub n is a sub 1 plus n minus 1 times d. So starting with that formula, a sub n is a sub 1 plus n minus 1 times d. So I want a sub 10. So in this problem, n is going to be equal to 10. So a sub 1 is a negative 1. Plus, I want 10 minus 1, and the difference is a fraction 1/2. Okay, that gives me a sub 10 would be equal to negative 1, and this will turn out to be 9 times 1/2, or 9 halves. And then that gives me a sub 10. This would be like 2 halves, negative 2 halves plus 9 halves, which would give me 7 halves. So I now know that the 10th term is 7 halves, and I'll go ahead and write that up here, is 7 halves. So now I'm ready for the third step to find the sum. So on step 3 would be to find the sum of the first 10 terms. So again, starting with the formula, and we'll go back and take a quick look at it here. It's just this right here. So S sub n would be equal to n times a sub 1 plus, in this case, a sub 10, all divided by 2. Now we'll plug in what we know. So we want the 10th, the sum of the first 10 terms. N is equal to 10. The first term was a -1, plus the 10th term was 7/2, all divided by 2. So the sum of the first 10 terms, this will turn out to be 10, and I'll, just to put it in right form, this will be -2/2, then plus 7/2, all divided by 2. So that's going to give me 10 times, and this would be 5/2 divided by 2, which would give me, and then I can cancel out 10 and the 2. This would give me 5 times 5/2, which would give me 25/2, and that's going to be the sum. So if you were to add all these up, you'd come up with 25/2. So this was just an example that involved fractions. So you had 3 different examples there. The first one involved positive difference. The second one involved a negative difference. And then finally, this third example involved fractions. But they're all based on this rule right here. But remember, when you find the sum of an arithmetic sequence, there's a pretty good chance that you're going to have to find that nth term first. So you may also need this formula right here. So some combination of those should give you the correct answer. So anyway, there's a couple of samples of how to find the sum of an arithmetic series.